Good day, everyone. We are reviewing Wetzel's Limnology textbook, edition number 4, chapter 4, Rivers and Lakes, Their Distributions, Origins, and Forms, by Bernard Lehner. Distribution of inland surface waters. The amount of terrestrial surface water on Earth is very small in comparison to the water of the oceans, but inland waters have much more rapid renewal rates. On a volumetric basis, terrestrial surface water is concentrated in the deep water bodies of several very large lakes. The saline Caspian Sea forms the largest lake on Earth with a volume of 75,600 cubic kilometers, representing 41% of global lake volume, followed by Lake Baikal of Siberian Russia, the largest freshwater lake, which contains another 13%. The number of individual depressions of smaller lakes and reservoirs, however, is extremely large, and most of these lakes are located in temperate and subarctic regions of the northern hemisphere. Most lakes are shallow and their form is quite transient. For example, they are continuously changing their shape over short or long time scales. Large-scale events in past geologic epochs, driven largely by glacial, tectonic, and volcanic activities, have aggregated many lakes into lake districts. The morphometry and geological substrata of the drainage basins are very important because these properties influence the formation of interconnected river and lake ecosystems. Their sediment-water interaction and the resultant productivity. Shallow lakes, which have more sediment area per unit of water volume, are generally more productive than deep lakes, and a greater proportion of their total productivity is attributable to communities of the littoral and wetland areas at the land-water interface. Water presence on the Earth's terrestrial surface is highly variable in space and time, both seasonally and in the long term. The consistent acquisition of satellite imagery since the early 1980s have revealed how lakes and river networks expand, contract, and shift with seasons, climatic changes, and human activities. Current estimates indicate that rivers and lakes cover less than 3% of the Earth's terrestrial surface area, with a combined total of about 4 by 10 to the 6 kilometers square. Their extent is fluctuating due to natural and anthropogenic causes. For example, from 1984 to 2015, about 14% of mapped permanent water bodies were spatially or temporally variant. Further adding wetlands, floodplains, and transitional systems, the total extent of terrestrial surface water may exceed 12.1 by 10 to the 6 kilometers squared, representing more than 8% of the Earth's land surface. Rivers, covering an estimated area of 0.8 by 10 to the 6 kilometers square, form large networks that dissect continents with a great geomorphic and hydrologic diversity of characteristics, from mountain headwaters to ocean outlets. Their width and depth are far more dynamic than those of lakes, as they are more responsive to the hydrological cycle and its seasonality, and it has been estimated that more than half of all rivers and streams cease to flow at some point during the year. Given their importance for water supply, most human settlements are located along the meandering path of a river. Lakes comprise the majority of the world's permanent inland surface waters, with an estimated area of 3.2 by 10 to the 6 kilometers square. Most are located above 40 degrees north in the northern hemisphere and can be categorized by various types of origin. As part of this coverage, humans have created about 0.3 by 10 to the 6 kilometers square of artificial reservoir surface area, mostly over the past century. Rivers and streams. Rivers and streams are estimated to cover an area of 773,000 plus or minus 79,000 kilometers squared, which represents about 0.6% of the Earth's land surface. All river channels combined store a total of about 2,000 kilometer cube of water, which represents less than 0.005% of all freshwater stocks on Earth. Despite these low quantities, running waters are of enormous significance for aquatic ecosystems and play a key role in biogeochemical cycles. Erosion and sediment transport in rivers move large amounts of dissolved and particulate matter from the land to the sea, estimated at about 19 billion tons annually. Rivers also provide a range of critical services that directly benefit humans, such as energy for hydropower generation, transport pathways, and water provisions, as most water that is withdrawn for human use originates from rivers. The global network of all rivers and streams, with a long-term mean annual flow of at least 100 liters per second, has been mapped to exceed 24 million kilometers of total stream length. Small streams and rivers often flow from high elevation mountainous areas, feed into lakes, and eventually converge to form large river systems. 7 major river basins exceed 1 million kilometers squared in drainage basin area and reach or exceed 5,000 kilometers in main stem length. So, for example, we have the Amazon Reach, that the Congo, the Mississippi, Missouri, and the Nile, the Ob, Irtysh, and then the Yangtze, and then the Yenisei, Angara. Among them, the Amazon has by far the highest river discharge, with a mean annual flow of more than 200,000 meters cubed per second. Even its main tributaries exceed the size of most other global rivers. The ecosystem processes, biodiversity, and services, however, that the world's largest rivers support are threatened by anthropogenic impacts on their connectivity, mostly caused by dam and reservoir construction. Only 37% of rivers longer than 1,000 kilometers remain free-flowing over their entire length, and only 23% flow uninterrupted to the ocean. Lakes and reservoirs. The total number of lakes on Earth is not exactly known, but has been estimated to be around 21 million, considering lakes with an area of at least 1 hectare. However, only less than 1% of them are larger than 1 kilometer square. When including even smaller lakes and ponds, estimates reach between 117 million and 304 million. More recently, humans have built a substantial number of reservoirs and artificial ponds. Most of the world's lakes were formed by glacial, tectonic, or volcanic processes, and thus many lakes are organized in lake districts that comprise water bodies of similar age and origin. Glacial activity during the most recent Pleistocene period of major ice advance and retreat ending 10,000 years ago created millions of small depressions that subsequently filled with water. Consequently, large numbers of lakes are found in regions of the northern hemisphere where the land masses of North America, Europe, and Asia interface with glacial movements. In particular, countless small shallow lakes are found throughout the Arctic, subarctic, and northern temperate zones. While lakes can be grouped according to their origin and formation, they can also be distinguished based on their salinity into fresh or salt water. Most inland, for example, athalastic, salt or saline lakes occur in landlocked depressions without a surface outlet, also called terminal or endorheic lakes, which can mainly be found in semi-arid and arid regions. In endorheic lakes, dissolved salts and minerals enter the lake through inflowing water or groundwater fluxes and accumulate as the water evaporates from the lake surface. Over long timescales, this process increases the salt concentration in the lake. Many endorheic lakes that occur in arid climates are ephemeral, forming large salt flats that only episodically fill with a shallow layer of water after heavy rainfall event. Other exorheic saline lakes exist due to the geologic reasons. Or along the marine coastline, saline lakes can be classified according to their salinity in gram salt per liter, ranging from slightly saline or brackish to saline and hypersaline, although there are different conventions on what values are used to separate our different classes. The total water volume stored in global natural lakes that exceed 1 hectare in surface area has been estimated to be around 182,900, which constitutes about 94% of all non-frozen surface inland water stocks on Earth. The majority of this water, however, is contained in a small number of very large lakes. The Caspian Sea, a saline lake, is the largest inland water body, both in terms of surface area, 377 kilometers squared, and volume, 600 kilometers cubed, while Lake Superior, 800 kilometers squared, and Lake Victoria, 200 kilometers squared, are the largest freshwater lakes in terms of surface area. The most freshwater volume is contained in Lake Baikal at 600 kilometers cubed, and Lake Tanganyika 18,900 kilometers cubed. The Laurentian Great Lakes of North America, mainly Lake Superior, Michigan, Huron, Erie, and Ontario, constitute a collective volume of 22,600 kilometers cubed and an area of 100 kilometers squared, making them the largest contiguous area of non-frozen freshwater in the world. Lake Vostok, the largest known subglacial lake on Earth, lies approximately 4 kilometers under the surface of the East Antarctic ice sheet, and it is estimated to be the 6th largest lake in the world by volume, about approximately 5,000 kilometers cubed. About 350 lakes exceed 500 kilometers squared in surface area and contain approximately 172 800 kilometer cube of water. For example, 95% of all lake volume. Of these, 20% are saline lakes, including lagoons, and 25% are human-made reservoirs. About 90% of all lakes occur north of the 40-degree north latitude, and more than 2/3 of the world lakes are located in North America, while other areas of high lake densities can be found in Scandinavia and Siberia. So before we move on, why don't we look at this map that shows the large river network in the world, and so that maps it, as well as on the right that shows the compiled area of these rivers. So we see a couple peaks. We see a peak that corresponds to the Amazon basin south of the equator, and this is the Amazon basin right here. And then we see a peak for rivers that are like, north of the 40-degree north parallel, as explained in the text, and due to very large rivers, especially in Russia, central Russia, and then also subantarctic and Arctic North America. And this is a table that shows the distribution of river basin in the world, and by main channel length, drainage area, the mean annual discharge, the limnicity, the forest extent, cropland extent, and the population as of 2010 in millions. So what can we gather from this table? So the first thing we can gather from this table is that it's pretty well distributed. So if we look at so we have 135,000 kilometers squared of drainage area, and by 10 to the 3. And so most of it is located in Africa, and large share is taken by Congo, Niger, Nile, Zambezi, and then Orange Basin area. We have then second in that, we have Asia at 28,000, Europe at 23,000. So in Europe, we have the important rivers being the Lena River, the Ob-Istrish River, and then the Volga. And then in North America, we have the Mississippi-Missouri network, as we would imagine, the Mackenzie River, which is in northern Canada, and then the St. Lawrence. And then in South America, we have, of course, the Amazon Basin, and then the Paraná-Paraguay River Basin. So this map shows the distribution of lakes in the world. So instead of having somewhat of a bimodal distribution that we just saw in rivers, here we are dealing with pretty much like a high incidence of lakes north of the 40-degree north latitude in the world. especially concentrated in North America, as you can see here. And that is due to the fact that we don't have a lot of northern region with northern climate in the southern hemisphere. I mean, we basically have like, the tip of South America, Patagonia, that would have a similar climate that is found in the northern latitude of North America. And then, of course, like in Europe, we're seeing a lot high incidence of lakes, especially in Scandinavia, and then in central Russia and in Siberia. About 35 lakes are known to be extremely deep, in excess of 400 meters. Lake Baikal is the deepest lake on Earth, with a maximum depth of 1,620 meters. Nearly all extremely deep lakes are of tectonic or volcanic origin or have formed from fjords that have subsequently become fresh. Although a few lakes of glacial origin, such as the Laurentian, Great Lakes, and Great Slave Lake of Canada, reach great depth, few exceed 300 meters. Most of the deep lakes are found in mountainous regions along the western portion of North and South America, of Europe, and of Central Africa and Asia. Lakes Baikal and Tanganyika are the only lakes known to have maximum depth in excess of 1,000 meters and mean depth of over 500 meters. Numbers and size estimates of very small lakes and ponds are typically extrapolated using statistical techniques and scaling laws. Most of both natural and artificial lakes are small and relatively shallow, usually less than 20 meters in depth. A vast number of lakes in the subarctic regions are particularly shallow, with mean depth of about a meter. In addition, over half of the total global lake shoreline length of 7.2 by 10 to the 6 kilometers for lakes greater than 10 hectares is found around the smallest lakes in the range of 10 to 100 hectares. Because of these morphometric characteristics of small and shallow lakes, a large portion of their water volume is exposed to and interact with the chemical and metabolic processes of soil, sediments, and coastlines, and their ability to develop sessile littoral flora generally results in markedly increased overall productivity. So that concludes the subchapter 1 of chapter 4 of the Wetzel's Limnology textbook, edition number 4. So I will see you soon. Thank you for your attention.